exponents, if you remember Aiden talking about it, he said, why don't we add the exponents together when we were adding? Well, that's because we were adding and not multiplying. So we got to remember our multiplication rules and what we do with exponents. So if I had something like x squared times x to the third, I would get what? X to the sixth or fifth? Fifth, right? Remember you add 3 plus 2. If it was x squared to the third, that's when you would multiply, right? But here we're just adding. So we're going to be adding exponents when we multiply polynomials because I'm going to be taking a monomial times a monomial, which means I will be adding the exponents. Alright, so if you look at this first one, I have a monomial, a cubic monomial, 6y to the third, times a quintic monomial, 3y to the fifth. So if it helps you, the commutative property of multiplication allows you to move all of these terms around, because essentially what's happening is it's the same as having 6 times y to the third times 3 times y to the fifth. And then I could move my constants together using the commutative property, the 6 times 3. And then I can move my y bases together, so y to the third and y to the fifth. You don't need to do this every time. I'm just showing you how it all works. So if you do 6 times 3, we get 18. Y to the third times y to the fifth would be y to the 8th. So you add your exponents when you multiply. Do you need to do this each time? No. If you would just look up here and say 6 times 3 is 18, y to the third times y to the fifth is y to the 8th, that is fine. Okay? So that would be your answer.
Basically like the same thing with the math, like on chapter.
Yep. Exactly. So what about this one? What do you think is going to happen here? 27 m to the third, n to the third. Good. If you don't see that, you can rewrite it. I could do my 3 times my 9 together. I could do my m to the first times m to the second times n to the second times n to the first. So 3 times 9 is 27, 1 plus 2 is 3, 2 plus 1 is 3. And get your final answer. Different than adding and subtracting, because now we're just multiplying everything. So can you do a monomial times a monomial? Okay. Now let's do a monomial times a binomial. Or here it's a trinomial. So we've got 4, which is a constant monomial, times 3x squared plus 4x minus 8. So we've got a quadratic trinomial. All we're going to do is just use the distributive property. You guys should be used to using the distributive property. So I'm going to distribute that 4 to my first term. Well, 4 times 3 makes 12. There is no x next to this 4, so my x squared would just come down. 4 times 4x would make 16x. 4 minus 8 times negative 8 would be negative 32. Good. Well, I don't have anything to combine, so I'm done.
Combined 12x squared and plus 16x?
Nope, because that has an exponent of 1, so they're not like terms. You only combine them if they are like terms. So if they both had an exponent of 2, then you would combine them together. Thanks.
What if the 4 had x next to it?
If the 4 had an x next to it, good question. So then it would become x to the third, 16x squared, 32x.
I have a question.
Yeah.
Actually, can you just come here?
Why can't you ask it out loud?
Because,
Does it have to do with your homework?
yes.
No. Wait until we're done with this. Then maybe your question will get answered. All right. How about this one? 6pq times 2p minus q. What will be the first distribution? 12p squared q. Good. Because this is a p to the 1, this is a p to the 1. 1 plus 1 is 2. The q doesn't have a q to multiply with, so it comes down as q. Second. Yeah, negative 6p q squared. Okay? So we're good with a monomial being in front of my polynomial. No? Did you say no, Rory? Oh, I thought someone said no. We're okay? All right, now let's put a binomial in front. Are you ready? All right. Going through. So here I have a binomial times a binomial. So x plus 3 times x plus 2. Now, what I refer to, because I like to think of it as double distribution, because that's technically what you are doing. If I did not have this plus 3 here, and I distributed that x, what would you get? X squared plus 2x. If I were to cross off the x and distribute the 3, what would you get? Is that in standard form?
Yeah.
Almost. What would I do with this?
5x squared.
To make 5x squared. So we get x squared plus 5x plus 6. So what I did was I double distributed. So if you hear me say the words double distribute, that means you're going to distribute twice. You're going to distribute with the first term, and then you're going to distribute. No, because if I had 2 x's and I had 3 more x's, I have 5 x's. I don't have 5x squareds. Like if I literally made 2 x's and then I added to it 3 more x's, I have 5 x's. They don't all of a sudden become x squareds.
But
2 x's plus 3 x's makes 5 x's. Right. You're adding them together. 2 x's plus 3 x's make 5 x's.
What?
If you had 2 apples and you add 3 more apples, you have 5 apples.
yeah.
So instead of apples, we have x's. So if I literally made wooden x's and gave you 2 of them and then gave you 3 more, you would have 5 of those x's in your hands.
Yeah, what would the x be squared though?
No, you're not multiplying. You're just adding. Okay? So, double distribute. Sometimes you'll hear teachers, there's a bunch of teachers here that like to use an acronym called FOIL.
What?
So if you want to jot this down.
Hey, we just learned that and like you're like, yeah. They're going to
Like nouns and math.
contrast.
Really?
Like why two
It's like
people.
when two people with different personalities like contrast each other to show a difference.
It's
Oh,
like a person that brings out the personalities and the
I didn't know that. Well, this is just an acronym, so it's not the word FOIL. It's just the words we're going to use start with the letters for FOIL. So another way to remember how to multiply a binomial times a binomial is first outer, inner, last. FOIL.
First, outer, inner, last. What does
So
that
first
mean?
one,
I'll show you.
the first one in, and then, oh wait.
So if we go back to the last example that we just did, so we know that we get the same answer using this method. So we have FOIL written down. First, inner, or first, outer, inner, last. So if you get to a further math class and they say just FOIL it, you should know what that means. So what are the first 2 terms of both binomials? X. So x times x gets you to x squared. FOIL. FO. Outer. What are the outer terms?
3 and 2.
The outer is the x and the 2. They're on the outside, right? So that would get you the 2x The 3 and the x are the inner to get to 3x. And then the last would be the 3 and the 2. Okay. Sometimes foil's fun because I think it makes like a little
it's really pouring right now.
man. Does that not look like a little man?
Looks like a pumpkin.
That looks like a pumpkin?
Yeah.
Combine your middle two
How does that look like a pumpkin?
to get 5x plus 6.
It looks exactly like a pumpkin.
Oh,
Yeah, I know.
it's smiling.
Yeah.
No, it looks like Squidward. That long.
It's got the
How
nose.
does that look like Squidward? It doesn't have a nose.
Here's his tongue.
Did you mean to do that?
Yeah.
Oh, it looks like Squidward on a
No,
stage.
she did.
Okay.
I was just thinking that.
It's like the motivational speaker that was here on Wellness Day. Make whatever you can out of the scribbles. Yeah. Yeah. So x squared plus 5x plus 6. Foil. Got it? You can use whatever method you want. It gets you to multiply everything no matter what. Me personally, I just do double distribute because that's the way I see it. But if you want to foil it, foil it. Just going to change your order. If you double distribute, you do your first. So s times s gets you s squared. But then instead of doing the outer, well, yes, you do the outer, right?
Yeah.
Yes, that's the outer, so that's negative 2s. And then the next would be your inner, right? Taking your 4 to everything. So plus 4s, last, negative 8. So it gets you the same lineup. So it'll be s squared plus 2s minus 8. Okay? Foiling. Let's do one more foil or double distribute, whatever you want to call it.
Yeah, it is really pretty.
It is, isn't it?
Yeah, let's go out.
Can I erase it? Last example. Here we go. Ooh, I lied. 2 examples. We gotta cover this. If you have x minus 4 squared,
X squared minus 16.
when you square something, that's the same as doing what? Like if I had x squared, that's the same as x times x, right?
Yeah.
So if I have a binomial squared, that means I just have that binomial twice.
Yeah.
So whenever you see a binomial to the second power, you're just going to rewrite it twice. Then multiply. X times x is
2x.
x squared. X and a negative 4 makes negative 4x. Bless you. Negative 4 and an x makes negative 4x. Negative 4 and negative 4 multiplies to make positive 16. Combine your terms in the middle to make, so we x squared minus 8x plus 16. What would have happened if my original problem here was not this and had a plus here instead of a minus?
Would they both have a plus?
Would this stay a negative 4x?
Zero.
No.
This would then go to a positive 4x, and then what would happen? It would go to 0, right? And then it would just be x squared plus 16. All right, that's it. We're done. So you should now be able to do your homework.